Hello everyone, we are going to be solving 2561 rearranging fruits. This was a daily Leetcode problem given on 2nd August, right? That was Saturday. So before starting this problem, we shall have a small motivational quote. Fools arrogantly believe they all have the answers. They have all the answers, shutting out new ideas and growth. In life, humility opens doors to knowledge while overconfidence leads to mistake and stagnation. Wisdom isn't about having all the answer. It's about recognizing there's always more to learn, staying open minded, question your assumptions, and you'll grow wiser every day, right? So, you should always be open to listen to others and accept there is always improvement from whatever you have today. Okay, so let's look at this problem. This is an hard type problem. Uh, you are you have two fruit baskets coming containing n fruits each. You are given two zero index integer arrays, basket 1, basket 2, which represent cost of fruit. You want to make both baskets equal. To do so, you can use the following operations as many times. Choose index ij, swap ith fruit from basket 1 with jth fruit in basket 2. Cost of the swap would be min value between basket 1 of I, basket 2 of j. Two baskets are considered if equal if sorting them according to the fruit cost makes them exactly the same baskets, right? So return the minimum cost to make both the baskets equal or minus 1 if impossible. Basket 1 422 4222. Basket 2 has two ones with 4 and 2, right? Let's observe this one. So let's say there are 4 2 2, and in the other case we have 1 4 1 2, right? If you see, these two can get cancelled out, while we have here a 2 and 2, right? This has surplus value of 2's and this has surplus value of 1. We can consider, let's say there is uh, let's say a butterfruit, two butterfruits in the basket 1 and two mangoes here. So I the basket one can trade one butterfruit to this one, so that this can take up, instead of one, this can, one butterfruit goes to this one and one mango goes to this one. So that's a simple idea. And how can we do that, and what is our solution approach, is what this problem is having to ask. If there is no swaps that are possible, then we need to return minus 1, which says that we cannot make both baskets equal, right? Okay, so the approach that we can take to solve this problem would be, the approach that we can take to solve this problem is some sort of a map to uh, keep track of all the fruits in both basket 1 and 2. And we know that we can do this with a single map, because if a value is even, then we can say that we can trade one with another. Else, if both have odd values, then there is no chance of trading it. So this example too demonstrates that better. So what I mean to say here is, let's say we have this example where, let's say, 2 3 4 1 and 3 2 5 1. It is impossible for us to, let's say, we create a map with both. We can cancel 3 2, this and this, while this has 1 1 quantity. Let's say this has 4, this has 1. Let's say this is apple, this is orange. We can still cancel out these two, but let's say this one is uh, uh, guava. uh, Basket 1 cannot share any other fruit with basket 2 because both have one only, right? So in such a case where both quantities uh, are only odd in number, or maybe odd numbers are something like 1, 3 or 5, right? So then we can say that there cannot be sharing of the fruit, thereby we cannot make both the baskets equal, right? I hope you get the idea. And as I said, let's say here if we keep track of all the unique values, right? So let's say 3, 2, 1, 4, and 5. We get this as 2. That is, in we are counting for both baskets. 2, 2, 2, and 4 is seen only in basket 1. Let's say 5 is seen only in basket 2. This means that these two values are totally specific to basket 1 and basket 2, and therefore they can never be shared between the two baskets because they are only one in quantity, right? So that's the whole idea. So, and as I said, we will use a single map and count all of the frequencies for both basket 1 and basket 2. While we do that, we shall also keep track of the excess values. uh, this is We keep track of excess values. Like for example, we can iterate through this map and we can take key value of the map that we have built, and if any of the value mod of 2 which says if it's not even, then we can say it cannot it can never be shared, or we are returning -1 saying that they cannot be equal, right? If this criteria is passed, then we can say that we can push excess dot push of all the values. We are always going to do excess uh, we are going to consider value divided by 2 because we would have this map being calculated for both basket 1 and basket 2, 1 and 2. So that way we are going to keep track of this one, right? And finally, once we have the excess value sorted, then it's time for us to distribute these values. So we can simply sort this excess array which contains all the values that can be shared between the two baskets just to make it equal. So we can distribute it this way. So we can distribute them, and the main goal is to find the cost. Cost is nothing but math.min of excess and two times global value. So where did this global min value come from? I will just explain. Just We would have calculated global min just this way, where uh, this will be basket 1 of I, comma basket 2 basket of j. This is the min value that we are going to calculate, or global min, which we are going to assign as global min as initially 0, and this would be the minimum value. And excess will say that it's the minimum operation that if the array contains, let's say if this access array contains uh, 2, 4, 5, and what would be the minimum value here, right? So the way to do that would be math.min of x's, and so in order for us to understand our approach better, I will take the example one and do a dry run on it so that we can uh, agree upon the approach that we are looking forward or extending towards, right? So I will take the example one in a new sheet. So we had our example one, which was containing 4, 2, 2, right? So firstly, we said that we will be forming a map uh, such that we iterate through any of these arrays because both will have the same length, and we form the values such that 1 minus 1. So if we see this in basket 2, then we apply minus 1 on it, and let's say if we see it in basket 1, we increase count 1 and also minus 1 here since they both are satisfied. And when we move to this index, we see another 2, so we increase 1, and here we see a new value which is 1. So we say minus 1 here, because basket 2 contains it and basket 2 is deficient of it, right? So another 2 which we already have it here, so we increase it here. So in order for us to uh, form the map, we have 4 which contains 0, which means it's a balanced value, and 2 which is uh, occurring 2 times, while 1 is occurring minus 1 time, right? So now in order for us to form the excess value, we create this excess value such that we go over this map and we calculate uh, if the specific value mod of 2 is not equal to 0, and uh, its value is not equal to 0, and we also divide this value by 2. For example, in this case 2 is occurring 2 times, so we only need to consider one excess value because this is part of the split or the share that we are going to send it to basket 2. I hope that makes sense, right? So once we do that, uh, here this would not give us any excess value. So in this case 4, we are not going to push it to the excess value, while we are at this value or this key, we see this is mod of this is not equal to 0, 2 mod of 2 is not equal to 0, and we push it to the we push this value 2 divided by 2, 1 value. We push this key as this is an excess value that can be shared to another basket, and we see this one, this is also mod of 2 not equal to 0. So only 2 minus 2 is the only excess value that can be shared, right? Once we have that, so we can sort this uh, and we can calculate the cost. Once we have this excess value, say we can calculate the cost with math.min of excess of I, that is this value 2 that can be swapped with any of the minimum value. This is the only value that is uh, containing minus 1 deficit, right? So we can swap it with this one. This one had a value of 1, that is plus 1, right? So this will take up the key value, not the value part of the map. So that's what we had written in this case, right? So global min value will be this way. I will write in pieces of code snippets. Maybe that should help us clarify what our approach is. Please do let me know in the comment section if any piece of explanation was a little tricky to understand. But yeah, I try to explain this to the best. Okay, so I will start coding this up. As we discussed, the basket 2, we are going to subtract it just to balance the basket 1 and basket 2 and find all the uneven or the excess parts that we can share, right? So, and at each point, we are also calculate the minimum possible value that we can use to swap. Look at the way that we are calculating the global min. This would be an pointer which will give us the minimum value in both the baskets 1 and 2, right? And this will be later used to make the cost efficient swap, that is making the min cost to make both baskets 1 equal. So this is the minimum cost to make both baskets equal. So this is where the global min logic will help us. So okay, so this should solve our problem. The time complexity of the solution would be O on n log m because we are also sorting the excess array, and space complexity would be O of n because we are storing hash map here. So basket two. While this gets processed, I would want you guys to tell me what do you understand when we are doing this 2 into global logic into 2 times, right? So I can explain, but take it as an logical puzzle to uh, post your thoughts in the comment section. So that's a point. Count entries. Okay, let me see. Count entries method. This should be a. As you can see, the solution gets submitted. Please do post your thoughts on why this has been multiplied 2 times uh, for this problem. At least this would help me understand what the thoughts uh, around having to use 2 times global min logic in this algorithm or the solution approach that we have opted. Right. Hope you found this video helpful. Looking forward to hear comments going from each and every one of you. Thank you.